Alright, here are solutions to quiz 8 from Math 65. Basically what we're given is a bunch of equations that we're supposed to solve for x, and the way we will do that in each of these problems is by factoring. So if you're going to solve an equation by factoring, you first of all want to set it equal to 0. So what I can do is I can subtract x and subtract 15 from both sides of this equation to change this into this. And then what I have is a equation. There's no greatest common factor. It's a trinomial, and the leading coefficient is not a 1. So we have a method for solving these. The first step is to find two numbers that multiply to negative, well, let me write this all out, that add to the coefficient on our x term, so they add to negative 1, and they multiply to the product of the coefficient on our x squared term and our constant term. In other words, they multiply to negative 30. So you have to find two numbers that add to negative 1, multiply to negative 30. You can make a little list of everything that multiplies to 30 if you want, or you might be able to just see what the answer is right off the bat. Either way is fine. But if you make a list, eventually you'll get to 5 and 6, and you'll say, all right, if I want to multiply to negative 30, one of these has to be negative. If I want to add to negative 1, it should be negative 6 and positive 5. So this and this. Okay, so I found these two numbers, and then what you do is you go over here and you replace your middle term, your negative x, with positive 5x and minus 6x. And then we can factor by grouping. So the greatest common factor between these first two terms is just an x. The greatest common factor between, well, that's not true. You look at these next two terms and you want to pull out something so that you're left with 2x plus 5. I think that something is a negative 3. And now you're left with two terms, they both have a 2x plus 5 in them. So if you factor that out, you get a 2x plus 5 and an x minus 3. And so what you have is a product of two things that equals 0. The only way you can multiply two numbers together and get 0 is if the first one is 0, so 2x plus 5 equals 0, or if the next one's 0, if x minus 3 equals 0. And 2x plus 5 equals 0, that's the same as saying 2x equals negative 5, so x equals negative 5 halves. And over here, x minus 3 equals 0. If I add 3 to both sides, I get x equals 3. So what I get are two solutions to this equation. X is negative 5 halves, and x is 3. And I can kind of do a similar method down here. Let's see, down here, same idea. I have this equation, 2000 x squared minus 2000 x. I want it equal 0, so if I subtract 4,000 from both sides, I'll set it equal to 0. And then you can look at this and you can try solving it kind of like we did up here, although you can get some huge numbers. You could get it to work. But what I was hoping you would see is that there's a greatest common factor. That we could factor out 2,000 from each of these terms. And if you do so, you're left with x squared minus x minus 2. And I think that'll be quite a bit easier to factor than these numbers here. We got a leading coefficient is 1. So that means that's going to factor x plus or minus something, x plus or minus something. So we need two numbers that multiply to negative 2 and add to negative 1. See, multiplying negative 2 and positive 1 would also add to negative 1. So we get to here. And so what that tells us, maybe I can jump up here, is I got three things getting multiplied together equaling 0. So either the first one equals 0, 2,000 equals 0. That's not true. X minus 2, maybe I'll say or. X minus 2 equals 0. Or x plus 1 equals 0. Well, 2,000 doesn't equal 0. There's no value of x that will make 2,000 equal to 0. These are different numbers. There's no solutions here. This one here, x minus 2 equals 0, that could happen. You could add 2 to both sides and get x equals 2. X plus 1 equals 0. You could subtract 1 from both sides and get x equals negative 1. So what we get for our solutions are that there's two solutions, x equals 2 and x equals negative 1. moving on. Let's see. So we want to solve this by factoring. Problem is it's not equal to 0. So what we'll have to do is kind of unfactor this. We'll first multiply. We'll do x plus 3 times x minus 3. You might recognize that from our difference of squares formulas. You could either use the box method to multiply these together, or you could just recognize that this is x squared minus 9. And now what we have is an equation that we can set equal to 0 by subtracting 8x from both sides. And if the thing on the left will factor, since the leading coefficient is a 1, we'll just have an x here and an x here. And then what we need to do is find two numbers that multiply to negative 9 and add to negative 8. Negative 9 and positive 1 will work. So what this tells us is either x minus 9 equals 0 or x plus 1 equals 0. And we could add 9 to both sides to get x equals 9. You could subtract 1 from both sides to get x equals negative 1. So there you go. We got two answers. X equals 9, x equals negative 1. On any of these, you could check your answers by plugging them back into the original equation. But I'm pretty confident we haven't made any mistakes, so I'm just going to keep on going. Last one here, we have 4 terms. No greatest common factor, but 4 terms, so that'll tell us to use factoring by grouping. You look at these first 2 terms and they have an x squared in common. So if you pull out that x squared, you'll be left with x plus 2. And then if you want to be left with an x plus 2 in these next 2 terms, you better pull out a negative 9. Now you have 2 terms that both have an x plus 2 in them. So you can factor that out and be left with x squared minus 9. And sorry, I should write this equal. Well, I'm going to change this problem a little bit. I need an equal sign. Maybe I'll say this equals 8. No, I'm just going to say equals 0. Good enough. I'm going to make that equal 0, so then I can say this equals 0 or this equals 0. But as I was saying, we're not done factoring because x squared minus 9 is a difference of squares. So we can factor it into x plus 3 and x minus 3. So now what I have are 3 terms being multiplied together equals 0. So either x plus 2 equals 0 or x plus 3 equals 0 or x minus 3 equals 0. And I can solve each of these. Subtract 2 from both sides, subtract 3 from both sides, add 3 to both sides. I get that x equals negative 2 or x equals negative 3 or x equals positive 3. If I can get a box around those, be all done. So those are the solutions. Again, you can check these by plugging them back into the original equation, but to save time, I didn't even bother doing it. So those are the solutions to this quiz.